In this example, we are being asked to solve the system using matrix methods to put it in row echelon form. Notice it does not say reduced row echelon form here, it's just row echelon form. Then use back substitution to solve. So in this particular example, we do not have to achieve the full reduced row echelon form. We just need to achieve row echelon form, which will make some of our matrix manipulations a little simpler, and then we can use back substitution from that point on. Now, the thing to notice about this system is that it is yet more complicated, right? We've got 4 equations with 4 unknown variables. So let's go through these one at a time. Equation 1 starts with f2 plus f3 minus 2f4 equals -3. Equation 2 says f1 plus 2f2 minus f3, and then no f4 term equals 2. And then equation 3 is 2f1 plus 4f2 plus f3 minus 3f4 equals -2. And then the last equation, f1 minus 4f2 minus 7f3 minus f4 equals -19. So again, don't let this intimidate you. This is just same kind of process we've been doing in the previous examples, just more variables this time. So the first thing we're going to do under the solution is we are going to write this as an augmented matrix, just like we've been doing before. So the first row is going to be 0, 1, 1, -2, -3. The second row is going to be 1, 2, -1, 0, +2. The third row is going to be 2, 4, 1, -3, -2. And then the last row is going to be 1, -4, -7, -1, -19. And then we have our partition line here. So this is our augmented matrix. And again, I like to just double check this, keep a second eye on it to make sure we didn't miss a negative somewhere. And it looks like we are in good shape here. Okay, so let's get started. Well, the first thing to notice is that we have a 0 in this first entry, which is not really where we want it. If you remember, the definition of row echelon form says that all rows with a leading 0 should be moved to the bottom, okay? Should be moved to the end of the matrix. So what we're going to do is we're going to say, let's interchange row 1 with row 4, okay? And again, look back in your notes. It does say row echelon form has all rows with leading 0s are at the bottom of the matrix. So let's swap rows 1 and 4. So we're going to have +1, -4, -7, -1, -19. And then rows 2 and 3 are staying the same for now. So I'm just rewriting rows 2 and 3. And here is the new row 4 all the way down at the bottom. Okay, so there we go. Now let's get started. Again, for row echelon form, we do want the lower triangle to be all 0s. We want the lower triangle to be all 0s, and we want the main diagonal to be all 1s. Now, if we wanted reduced row echelon form, we would keep operating on this until the upper triangle was also all 0s, but that's not what this problem tells us to do. It says get it in just regular row echelon form. So we do need a lower triangle of 0s and a main diagonal of 1s, and then from there we can use back substitution to finish it off. So let's start operating on this. Let's use row 1 to create a cancellation here in row 2 and here in row 3. So I'm going to say negative row 1 plus row 2 to change row 2. And then I'm also in the same step, I'm going to have the other operation, negative 2 row 1 plus row 3 to change row 3. So again, I'm using row 1 to independently make 2 adjustments. One is to knock out this leading 1 in row 2, and the second is to knock out this leading 2 that's in row 3. okay? And that's fine to do. It's okay to do two steps, two operations in one step, because as long as these two are not related to one another. Notice that, you know, rows 2 and row 3, we're not relating 2 and 3 together at this point. We're just using row 1 to do something to row 2, and then independent of that, we're using row 1 to do something to row 3. So, you know, row 1 isn't changing, so we're going to keep row 1 the same. And also, you know, we haven't touched row 4 so at this point, so we're going to keep row 4 the same. Now, let's look at this operation here, okay? Negative row 1 plus row 2 to change row 2. So that knocks out a 0 there, and then we're going to say positive 4 plus 2 is a positive 6, and then we're going to say positive 7 minus 1 is also a positive 6, and then we're going to say positive 1 plus 0 is a positive 1, and then we're going to have positive 19 plus 2 is positive 21. Okay, and let's do the next operation here. Negative 2 row 1 plus row 3 to change row 3. So this will create a 0 entry here. Then we're going to have positive, let's see, positive 8 plus 4 is a positive 12. And then we're going to have a positive 14 plus 1 is a positive 15. And then we're going to have a positive 2 minus 3 is a negative 1. And then we're going to have let's see, 19, probably do that in our heads, but that's, I think, 38, right? So we have positive 38 minus 2 is going to be a positive 36. Okay, I think we're in good shape here. I'm just kind of double checking some things, so make sure we didn't make any boo-boos. Let's see. Negative here is 0, and then positive 4 plus 2 is positive 6. Positive 7 minus 1 is positive 6, 1, and then 19 plus 2 is 21, and double check the next operation here. Negative 2, 0, negative 2 times this is positive 8, it's 12, negative 2 is positive 14 plus 1 is 15, and then positive 2 minus 3 is negative 1, positive 38 minus C. I think we're in good shape. Okay, so we're slowly getting there. The next step we want to do is, let's see if we can create some cancellations here, okay? Now, here you got some options here, but how about, since we know there's a 1 already here, how about we interchange row 4 and row 2, okay? So how about we say interchange row 2 with row 4. So that way we'll end up putting the 1, a 1 value in a place that it should be. All right, so row 1 is not changing. We're swapping, let me draw that partition line a little better. We're swapping row 2 and row 4. So here is the new row 2. Here's row 3. And then the new row 4 is 0, 6, 6, 1, 21. Okay. Now, you know, this will help us possibly avoid fractions for as long as we can anyway. So the next step we can do is we can say negative 12 row 1 plus row 2 to change row 2. So we're going to use I labeled those wrong. Negative 12 row 2 plus row 3 to change row 3, sorry. So we're using row 2 here to change something in row 3, and specifically we want to create a 0 term where this positive 12 is. And then in the same step, we could say -6 row 2 plus row 4 to change row 4. So again, we're gonna independently operate on row 2 to create a cancellation right here in row 4. So we're gonna do these one at a time, and again, we can do both of these in the same step because rows 3 and 4 are not being related together. So, we're just gonna repeat row 1 again. Okay, row 2 is actually not changing. Remember, we're just using row 2, so I'm going to repeat that. So let's operate on row 3. We get a 0 here, we get a 0 here, and then we're going to have, -12 plus 15 will give us a +3, and then we'll get, the next entry will be +24 minus 1 is a +23, and then we'll get a +36 minus 36 will be a 0 here, okay? And what about the operation on row 4? So we already have a 0 in place here. I'm accidentally putting little marks everywhere as my wrist is touching the screen. So what do we get here? We'll have -6 plus 6 is 0. And then we're going to have -6 plus 6 again is 0. That's convenient. And then we're going to have 12 plus 1 is 13. And then we're going to have 18. All right, 6 times -6 times -3 is 18. Plus 21 is 39. Okay, we're getting there. We've got the lower triangle. Notice that we have our lower triangle here of all zeros. That's what we want, but we still need the main diagonal to be all ones, right? So we're almost there though. So let's perform this operation. Let's say 1/3 row 3 to change row 3, and then let's say 1/13 row 4 to change row 4. So that way, all we're doing is we're multiplying each of these rows by a constant and creating the one values that we are looking for. Row 1 is not changing. Row 2 is not changing. What about row 3? 0, 0, 1. And then we're going to have 23 over 3, right? Keep that as a fraction. And then 0. And then we'll have 0, 0, 0, 1, and 3 here. Okay. Good. Okay. So sorry, I was just double checking myself. So we're looks like we're in good shape. So look at this. This is row echelon form. Notice that we have a lower triangle of zeros here, and the main diagonal is all ones. And now we can use back substitution, okay? Because that's what the problem told us to do. So we're going to say now use back substitution. You do not need to, do reduced row echelon form because the problem didn't ask for it in this particular case. So let's put this back in equation form, okay? In equation form, use the variables given. We're going to have f1 minus 4f2 minus 7f3 minus f4 equals -19. And then we have f2 plus f3 minus 2f4 equals -3. And then we're going to have f3 plus, oops, didn't mean to scroll there, plus 23 over 3 f4 equals 0. And then we actually directly have f4 equals 3 here, okay? So now this is back in equation form. We notice we're use the variables given. You will lose points if you change variables on me, okay? So we have f4 equals 3. That's great. And so now we can substitute this into here, all right? So what do we end up getting? We'll get f3 equals, what do we get for f3? Let me double check, make sure. Make sure I didn't miss anything. I'm getting a slightly different answer than what I have in my notes, so I must have skipped a step somewhere. Bear with me, hang on. This is good, identifying our mistakes. I do get f4 equals 3. But this implies that f3 equals negative 23, which that is not my answer in my notes. So, you know, let's see. Going back to maybe this step here. See if you can find it with me. This is just like if we were live in class. So negative 12 R2 plus R3, that knocks that out. Negative 12, 15. Negative 12 times negative 2 is positive 24. Minus 1 is positive 23. And then negative 12. Ah, look at that. Look at that. Maybe you caught this way earlier in the video. If not, fix it now, okay? That's a boo-boo right there. Negative 12 times negative 3 is positive 36 plus 36, right? What's 36 plus 36? 72. I'm going to write that in green here. 72. Made a boo-boo there, okay? And so then we get to this step where we said 1/3 row 3, okay? So we do have 23 over 3, but 72, yeah, 72 over 3 is not 0. It is positive 24. There we go. That's much better. Okay. Okay. And then this right here is not 0. It is positive 24. If you caught that earlier, then good for you. Nice work. Okay. So we say F3 equals 24 minus 23 is F3 will be equal to, here, I'll just work it out. It's 24 minus 23 over 3 times 3, which is 1, okay? Now we can substitute, into equation 2. So we can substitute this into this and then F3 into this. So we'll say F2 plus 1 minus 2 times 3 equals negative 3. And so what does F2 become? Be mathematically proper here. Don't just keep writing equal signs everywhere. What does F2 become? F2 equals negative 3 minus 1 plus 6. Now this equals 6 minus 4 is 2, okay? And now we substitute all of these values into the first equation. So F1 minus 4 times 2 minus 7 times 1 minus 3 equals negative 19. Again, be mathematically proper. What do we get? Negative 19 plus 8 plus 7 plus 3. So I get negative 1. So the system is consistent. And write the solution nice and neat. F1 equals negative 1. F2 equals 2. F3 equals 1. F4 equals 3. Box that in with a straight edge. And that is the solution to this problem.